Hello, my name is Magdalena Szafrańska and I want to tell about a model of dynamics of psychotherapies. I am studying at University of Warsaw and I developed this model on my PhD program. So I want to tell more about this. So let's go. We start for why it's worth it create model which describes emotional state client, therapist and client's family. Mental discords affecting society depression are in retrospect and increasing that humanity must face. They vary in nature from minor problem in everyday life causing increasing sadness and depression to significant mental problem. Discords ultimately leading to tragic events. From the patient's perspective, one of options for dealing with this problem is to use psychotherapist treatment. Significant elements influencing the course and effects of psychotherapy are the variables relating to both the characteristic of the patient and therapist. In addition, the properties of the therapeutic process, such as the influence of the therapeutic relationship, indicated as the relationship between the therapist and the patient, are also important. However, the creation of above is also influenced by other factors, not necessarily limited to the direct relationship between the therapist and the patient. Shaping the patient's well-being and will define their weakness should also significantly depend on the external environment surrounding the patient in everyday life. So now we focus on create a model. We must understand system of differential equation which describe emotional state. One of the three group or person are regarded to in our psychological problem. Let C of T denote the emotional state of client at time T. This equation describing the rate of change in the client's emotional state, where MC and BC mean respectively the parameter of international changes of the client's mood and his/her natural emotional state. Moreover, in our model, we would like to include additional term, reflecting. This is emotional change in the client's mood, which can be in general reflected by function EC of C. Let us assume that the emotional state of the client is also influenced by the external environment, understood here as individuals or a group of people with whom the client is in the same relationship. Denoting by E of T the influence of the external environment on the client's mood at time T. EC is current function describe the impact of the client's mood and environment on the client, and ME and BE describe the external environment. We assume that the social environment has a simple dynamics reflected by a linear right-hand side in equation. Let T of T reflects the therapist's mood during the therapy session, and ET is the function describing the intersection between the therapist and his/her client. Let KT be a non-negative constant, denoting the competence and skills of the therapy, such as selection of therapist technique to the client's condition, empathy in committed and caring. Now we see a model, and this is a free differential equation, and the dynamics of the client should remain unchanged under unchanged condition. This is if neither a variation in the trait parameters of the client nor any input from the therapist or from other social environments are introduced. Further, we will consider the following influence function. Let's see. This function the function which are in first differential equation, and this and this function we can see in second equation which describes emotional state clients. During analysis model, we will make use of the following assumption. We can observe that part of this assumption are associated with have our emotion, because if we are poor, we feel more happiness when we find money than when we are rich. Hence, third and fourth assumption. The last assumption is about periodic. This F4 is a function which described unstable emotional state clients. So we imagine this function. This is periodic. Now we consider equilibrium points our model. Equilibria of our model can be obtained by solving the following algebraic equations. Easy to solve is the third equations. This solution we mark E star, but we can observe that if on therapies doesn't influence clients, equilibrium points is KT plus BT over MT, and similarly for clients, if it's stable, so C4 equals 0, and on his or her doesn't influence therapies and environments, so client's emotional state converges to BC over MC. We see that we can reduce our system to equation, and this place we use E star. This is equilibrium point, the third equation. Now, we define two curves M and L which allow to find intersection point. This point will be equilibrium point our model. This formula is so difficult, but this is the right side equation to describe emotional state therapies, and this is right side equation which describe emotional state client. First, we look on a curve L. For curve F, we see that for MT greater than 0, from assumption 3, we conclude that TL is increasing if C1 greater than 0, and decreasing when C1 less than 0. Then TL is concave for C greater than 0 and convex for C less than 0 if C1 greater than 0, and TL is concave for C less than 0 and convex for C greater than 0 if C1 less than 0. Note that science assumption 3 holds if F1 of C equals 0 in fourth assumption for all C in domain, then TL is a linear function. And on the we see on the right side exemplary graphs curve L. Now we look on curve M. if we use implicit function theorem. On the right side, we can see exemplary graphs in this curve, but only if C4 equals 0. The domain of the function Tm depends on the value of the function f2. If f2 is bounded, then domain is bounded, and Tm of C tends to plus or minus infinity when C converges to the boundary of the domain. And now we determine the difference of derivative of curves TL and Tm. While this seems only an additional calculation at the point, but it's important to further analyzing the exist and stability of the equilibrium points. So this formula is very used for me in analyzes this model. And let's see that this formula use and next step. Now, let us first assume that the function f1 and f2 are bounded and c4 equals 0. In the case when C1, T1 is the only one intersection point of the curves L and M, we have TL of C1 less than Tm of C1. This is T prime L minus M of C1 less than 0. Consequently, if C1, T1 is a solution to our system of equations and this is formula less than 0, and there is no solution to system satisfying in this solution greater than 0, then model has one solution. That is the numerator of the fraction describing the slope difference of the derivatives TL and Tm. So why I present this formula earlier slides. Now we focus on two equilibrium points. So if system has two solutions, C1, T1 and C2, T2, C1 less than T2, numerator difference of derivatives TL and Tm less than 0, and this same formula equal to 0. And third case. If there are three solutions, do C1, T1, C2, T2, and C3, T3, where C1 less than C2 and this is less than C3, then this is formula less than for C1 is less than 0, for C2 is greater than 0, and for C3 less than 0. Moreover, if f1 and f2 are unbounded and TL of 0 no equal Tm of 0 and TL T prime TL minus M of C equals 0, this model has no solution. And case for C4 equals 0 and C1 and C2 less than 0 is similar. And easy to see the number of equilibrium points when C1 and C2 have a different sign is easy to imagine. So we focus on a case if C4 not equal 0. Then in these formulas for the curves L and M, the function f1 and f2 are dominated by linear terms, minus mtt and minus mcc. Where MC and MT greater than 0. Consequently, this is no different from case for C4 equal 0. So go to the next case. Now we assumption only F1 are bounded and C4 not equally 0. We get finitely many points of intersection of the curves L and M. And this situation we see on this figure on this slide. And is case third, we can obtain infinitely many solution to a system if we assume the F1 and F2 are unbounded and when L is included in the graph M. Observe this possible only in the case when C1 and C2 greater than 0 or C1 and C2 less than 0. It's easy to see that we get infinitely many points of intersection also when L is included in the graph M. Now we go to analyze the stability equilibrium points. So we checking stability equilibrium points. We can use Jacobian matrix. Let Pi equal TICIEI with E is a natural number beyond equilibrium. The stability of Pi is determined by eigenvalues of the matrix J of Pi. So this formula is very bad, but clearly lambda 1 equal minus ME and eigenvalues lambda 2 and lambda 3 satisfy the quadratic equation. Further analysis of the stability of the equation points use the Vieta's formulas to determine the root signs of the above quadratic equation. For show equilibrium points globally stable, we use a Lyapunov function. So I want to present one of many theorems of lemma which we can prove for this model. Is show only one which is very important for our analysis process. So let C4 equals 0 and C1, C2 less than 0, then the unique equilibrium points P1 is globally asymptotically stable as a solution to model. And I want to present a numerical simulation for this model because you can imagine what happened in this slide. So this solution is simulation is prepared for positive influence clients and therapists for each other. C4 equals 0, so clients is stable, and positive internal condition. First graph shows successful end of therapy. However, if the client begins the therapy in negative emotion state, the therapist fails as shown in second figure. It indicates that despite the internal increase in the client's emotional state, a sudden decrease is not scalable, the probable cause of which may be a decrease in both the emotional state of the therapist and the toxic influences of the environment. And this is second equation, second numerical simulation. Here the function f2 is given as a linear function. We can obtain finitely many equilibrium points. Moreover, the simulation indicated in figure shows the three of these equilibrium points are stable. This simulation presents possibly end of therapy scenario, but only one of them seems to be in line with our intuition. The first two graphs show that this case the therapy ends negatively, although the relationship between client and therapist was positive. However, it should be pointed out that it is possible to successfully complete the therapy as long as the initial positive attitude of both parties to the therapy is appropriately positive. The need to adopt the right attitude may be caused by the strong influence of the external environment and to life experience of therapists. I prepared many other numerical simulation, but I have a short time, so I present only 2. And it's all, so I thank you for your attention and goodbye and nice day. Thank you.